Hello everyone. Today we are going to learn about data analysis. Today we will be solving a question paper on data analysis, data structure as we say. This will be the paper we will be solving. Uh, you can just see the questions we are going to solve. We are going to solve 8 questions, the A and part B. Right now, so we will begin with the question number 1, which is asking us to tell the key statistic measures. The See, why do we need these key statistic measures? Is we need to have a feedback, right? A feedback form. We are getting a feedback form, which is upon how teachers act or how teachers behave. Teacher indirectly we are giving the ratings to teachers. So right, this is the feedback form and we need to get the information out of those feedback form, and we are going to use the statistic measures. Right, the first one is central tendency. This measure gives us the middle part, right? Around the middle part, it identifies the center, as it is written, identifies the center or typical value of the feedback essential for understanding the average sentiment. Here what we are doing is we are taking an average, we are taking a mean or a median that gives us that how an average student rates a teacher. Right. Now the second is dispersion. How we see dispersion. Dispersion is spread. Right. All students are saying something, and then there is a spread that it's like a branch something. We can understand it like that. That it spreads, it deviates. So that is there are two we think do standard deviation IQR. So it's written like measures the spread. High dispersion indicates polarized opinions, students strongly agreeing and strongly disagreeing. Right. The standard deviation tells us if the students strongly agree or disagree. If the deviation is high, then it is like students highly agree or not. Right. Now there is the third distribution shape or skewness reveals asymmetry. Negative skew implies most feedback is positive, right? So this tells us skewness. When the skewness is symmetric, asymmetric, so you will know that if it goes to positive, it's like the students don't agree with a fact, and if it's negative then they agree, right? Now we will go to question number 2. Question number 2, here we have been given a data set that is 13, 15, 16, 16, 19, 20, 20, 21, 22, 22, 25, 25, 25, 25, 30, 33, 33, 35, 35, 35, 35, 36, 40, 45, 46, 52, 70, 72. That's actually 72. And these are total 27 observations, right? Now here I have written the answers of the question. Actually we will see the next slide that how we got these. The mean is 29.96, the median is 25, mode is 25 and 35. It is bimodal. It is asked in the question that if it's comment on its modality, right? In IQR it's quartile range. It is 20 quartile 1 and 35 quartile 2, quartile 3 actually. Data shows a slightly positive skew due to outlier score of 72. It gives us a positive skew because of the 72. The difference between 35 and 72 is very much high, so it gives us like that. Now here in this slide you can see we have calculated the mean, which is sum of all observation among total number of observation, median number of observation plus 1 divided by 2, that is the term we will be getting for median, that is 25 the number, and 14th term. Then the third word is mode. Mode is the observation that is the highest frequency. Here 25 and 35 both have highest frequency. They both came 4 times. So the mode is 25 and 35. and the modality is obviously bimodal. As you can see, 25 35 both are equal in frequency. And then we, what is quartile? Right, quartile is we divide the data set in four parts, equal four parts, right? Now position 1, as it is odd, like total number of observations are odd, then we will be doing n plus 1, otherwise it would be n. So 1 by 4 into n plus 1 is equals to 1 by 4 into 20 at 7th term, which is 20. We get our quartile 120. Quartile 3, position 3 by 4 n plus 1, we multiply it and we will get 3 by 3/4 of 28, which is 21st term, which is 35. Right. Now mid range is minimum plus maximum divided by 2, which is 13 plus 72 divided by 42.5. Mid range is 42.5. Now on the other side of the screen, right hand side of screen, you can see I have drawn a box plot. Box plot indicates that first it is 13, then 20, then the median, that is 25, then we go to 35 q3 quartile 3, and then we go to the maxima is 72, right? That is shown in the box plot. Now we will be going to the next, see, this is the box plot summary, right? Five numbers, minimum 35, quartile 1, median, all right. And this is how we draw a box plot. On the right hand side you will see a image that tells us what is what in the box plot. You can understand from there. Interpretation is the median is closer, right? 25 is closer to quartile 1 than quartile 3, and the longer whisk extends to 75 72. So I said before that the skew is positive, right? It is because the difference between 35 and 72 is more than 25 and 20, right? And single high score pulls the mean. No, like mean is around 29.96, slightly above the median. So this is what we get on question number 2. Now we will be moving to question number 3. Question number 3, we have given a data set, and this is the range frequency. Now we calculate the cumulative frequency from the frequency, and we will calculate the median, right? We have to calculate the approximate median, right? So here we will be using the interpolation formula, which is median is equals to lower bound plus n by 2 minus my cumulative frequency divided by frequency into width. So we will put every value which is given below the formula, we will put it in the formula and we will calculate it. So the result we will get is 33, approximately it will be 33.44, right? This is the formula for median, and this is using interpolation formula, right? This is the interpolation formula for median, and from here we can see that median class is 21 to 50, that contains n by 2 for 50 for 1597 item. So now we will go to the next question. I hope this is clear. Lifelong learning feedback. Now here are the observation and answers of this. Now summary statistics, metric, mean, median and standard deviation, which is age is 46.44, 51 is the median for age, and standard deviation 13.22. Now productivity percentage is mean productivity percentage. So we have gotten a data set, like you can see in the question paper and get that. And productivity percentage 30.70%, standard deviation 9.25%, right? And then the observations we got from these answers are that mean 44.4 is less than median 49.5, indicates a negative left skew, right? A negative left skew. More older students participating. Productivity mean is almost equal to median, implies roughly symmetric distribution, like not particularly they are equal, but they are nearly equal, 28.76 and 30.70, so like almost. Now this is how we calculated it. Age, productivity, we have got the data here. And 5 number summary, the minimum 23 age is minimum age is 23, and quartile 1 39.5, median is 51, quartile 3 is 56.75, maximum is 61. Now productivity, if you see here, productivity for minimum productivity is 7.8, maximum is 42.5, quartile 3 is 33.93, and median is 30.7. Now quartile 1 39.5, which is for age, and for productivity it's 26.68. Now here a scatter plot, we have plotted a scatter plot versus productivity, right? So on the lower x-axis you will see the age, and for like first that is around 22 something, 23 22, and 23, right, 23 age. And you can see the first one, that is 9.5, then 26.5 for the same age. So you can see how we have been plotting this plot, right? Scatter plot versus age, scatter plot age versus productivity. Now we will be plotting QQ plot for age. uh, this is the plot for age, and then the QQ plot for productivity. It might not be visible because of the camera, but now dissimilarity matrix. Now, nominal data, simple matching. So, nominal data, what is nominal data? It is simple data, right? Simple matching, nothing extra. What it is, like departments, colors, what it does is mismatches divide by total attributes or total attributes. Asymmetric binary, Jacquard's Jacquard's dist, yes, no feature, ignores no matches, focus on shared yes, right? It focuses on, if you say yes, I say yes, then it is yes. It doesn't go on you say no, I say no, it doesn't match, ignores it. Now numeric data, Euclidean, Manhattan, score. So this gives us scores, GPAs, like grades kind of things. Geometric distance, vector in vector space. Now there are four, right? The term frequency vector, it is cosine dissimilarity or supermum distance. Now what gives us is maximum difference in keyword frequency. Open, what it is, like open text feedback keywords, right? Now these are the formulas, right, for cosine dissimilarity, and for supremum distance, nominal attribute, Euclidean distance, Manhattan distance, asymmetric binary attributes, Jacquard's dissimilarity, right? These are the basic formulas for what we have seen in the previous slide. Now we will go to the next slide, attribute and distance mapping, right? So here on the first page it is like all the answers here. For student profile, P is equals to my x1, x2, x3, x4, we apply specific matrix based on the data types, right? Attribute score 1, x1 score, x2 mentor, x3 views, x4 infra. Types numeric, nominal, binary, and ordinal. Recommended metric, Euclidean, simple matching, Jacquard, and Manhattan. Now you can see on the right hand side here, Euclidean versus Manhattan distance in machine learning. So how it is described, the difference it is, right? Euclidean, you can see it is a straight line, while on the other hand Manhattan, you can see they are like steps. So these are the difference between them. And now we will see how and what is the answers for the questions, right? So x is we have gotten the coordinates of x as 22 1 42 10, and on the other hand y 20 0 36 8. Now coordinate wise absolute difference x minus y, which is equals to my 2 1 6 2. Euclidean distance L2 D2 xy. Now root sum of xi minus xyi square, which gives us root under root 2 square plus 1 square plus 6 square plus 2 square, which is 45 root 45, which approximately gives us 6.708, which is approximately right. Now second one is Manhattan distance L1 D1 x1 x comma y, which is equals to my sum of x1 xi minus yi, which is 2 plus 1 plus 6 plus 2, which is 11. So Manhattan distance we know it is 11. Minkowski distance with p, right, it is d3xy, which is equals to my sum of xi minus yi whole to the power 3 and whole to the power 1 by 3, right. So now we can see what we will put the values in. We will get x square x cube 2 cube plus 1 cube plus 6 cube plus 2 cube whole cube 1 by 3. Now this gives us around 233 to whole to the power 1 by 3, which is like approximately 6153. And then the last is supermum distance L infinity, which is d infinity x comma y, which is max xi minus yi, which is equals to max 2162. And then we will have to find what is the maximum between 2162, and it's obviously 6. So here is our answer for supermum distance. Now we will go to the next question, that is approximating median in big data. Now what is big data? Big data is a warehouse that can stores like large amount of data. Now first one is quick select, an ON selection algorithm related to quick sort. So it just quick sorts it. It partitions data to find the kth element without fully sorting the array. It just sorts the data, and it doesn't sort the array, but to find the data, find the element which we are looking for, it just partitions them, like separates the data, makes them into parts, and then search for the kth element. Reservoir sampling for streaming data maintains a fixed size sample that statistically represents the whole stream, allowing median estimation. Right. So this is how reservoir sampling is. Now histograms summarizes data into bins frequency tables. We can then interpolate the median from the bin count. So that is. And then why the median is often preferred in large feedback data sets. In massive feedback systems, thousands of response, the data typically show pressure presence of outliers. Some students may give extremely low or extremely high rating, and that is what we have studied in the first question also. These outliers strongly affect the mean but do not affect the median. So this just says that some people might just do rate or do the marking like very high, some do very low, and it affects the mean, but it doesn't affect the median. So median is way more accurate in those cases. Now, for example, you see 4, 5, 7, 6, 7, and 100. So that you can see the 100, it is outlier, obviously. And the mean which it gives is 24.4, which is like misleading because you can see the numbers, they are like literally small numbers. 4, 5, 6, 7, and then the 100, it is very big number. And median on the other hand, it gives us 6, right? So you can do like a central thing, it is like okay, it's true, right? 6 is true. Now skewed distribution. Student feedback data usually show positive or negative skew. Most rating cluster around 60 to 80, but some go very low. This is because of the same outliers and positive skew, negative skew. It always like 60, 80, but some go very low. Mean shifts towards the skew, right? What is mean is we have seen the mean is misleading, right? So mean shifts towards the skew, median stays near the actual tendency. We are studying is why we prefer median, right? So Mean shifts towards the skew, and median stays near the actual central tendency, right? So mean is always like around correct. It doesn't go with the flow. Thus, the median gives a more accurate overall picture of student satisfaction where distribution is not symmetric. Thus, the right. So, if the distribution is not symmetric, then median gives us an actual picture of what the actual distribution says, not the outlier. Like it doesn't affect by the outlier, it doesn't affect by the positive skew or negative skew wherever the skew goes, whether it's symmetric or not symmetric. Mean gestures towards the skew, median doesn't. Median tolerates mass effects. When like we are dealing with thousands and millions of observations, some students may respond dishonestly, click randomly. So there are chances, like not always. We can see that there is truthfulness and honesty in the forms, like on the response. There are fake response, false response, response based on personal feelings, not based upon the actuality, the reality, right? So even a small number of noisy rating can distort the mean, right? If someone like goes so low and like rates 0, or someone goes so high and rates 5, but actually it's like the reality is 3.54 or around that. So the mean just goes with the flow, where here like mean changes, but the median remains unchanged, right? Unless more of the 50% of the data shifts, right? So 50% of data is big data, right? You can understand that 50% of data, it's not some random people doing uh, based on personal feelings, or random people doing it upon like go with the flow kind of people, right? 50% of people, 50% of data means that they are educated people, in that if they are going to the same uh, thinking, same place thinking, right? So, and even in this situation, median gives a more stable and reliable center score, right? Now the large scale platform use median like methods, right? So you can see how the large scale programs, large scale platforms use median like methods. They don't use mean, right? You can see Google ratings, right? You have used Rapido, right? So after Rapido, they ask you to give ratings. So if you somebody makes like, oh no, the weather was bad, one rating, or someone says, oh, okay, that ride was good, also good, but then also one rating. So these are the outliers. So median identifies them, like medians don't care about that. Median gives you the accurate answer. Now, Amazon product ratings similar to what Google ratings we have seen, or Rapido ratings that I said, that almost is similar. It doesn't go with like one rating, then five rating. It stays in the middle. It doesn't give like it's one, it's five. Then you will say that 2.3 rating, right? But it gives us accurate answer. Obviously, evaluation, right? Course evaluation, grades, right? Use median, trimmed mean, or percentile to avoid manipulation. So this is why median is preferred in large feedback data sets over mean. Now, question 8. Similarity rankings raw data. Right. Now, target profile 1.4, 1.6, ranking students based on proximity, like distance, Euclidean straight line distance, Manhattan grid based distance, cosine, angular similarity. Now, here on the other side, you can see like rank, student, Euclidean distance, and result. Now you see student 1, student 4, 3, 5, 2, right? So it's 1, 2, 3, 4, 5, but we have arranged them, and now you can see the Euclidean distance is 0.141, 0.224, 0.283, 0.608, 0.671. You can see the smallest distance, the most similar distance from 1.4 1.6 is 1.41, and then other distances goes like more. Now, how did we calculate the distance similarity to x-axis? We have computed Euclidean, Manhattan supremum and distances and cosine similarities. See, ranking most similar to least similar. So in the Euclidean, it is S1, S4, S3, S5, S2, Manhattan S1, S4, S3, S5, S2, same order, right? Euclidean same order. Supermum S1, then S3, S4 tied, and S2, S5 also tied. Now cosine similarly, largest to smallest. S1 is largest, then S3, S4, S2 and S5. So S1 is most similar to B, like honestly you can see that S1 is almost the first, right? S2 is the least similar. You can see S2 in Euclidean, Manhattan. Then in the supremum it's also S2. Then in the cosine it's second last, but like obviously it is uh, not so similar. And by the most measures. Now this is the table which shows that what is the vector value, what we got the Euclidean value, Manhattan value, supremum value, and cosine similarity value, right? And we have given these ranking S1 S2 based upon these. Okay, now we will go to the next slide. You can understand how we got the S1 S2 S3 rankings. And then the question arises, why normalization, why re-ranking, right? And first one is, what is normalization? Normalization converts vector into unit length. This removes the influence of magnitude, total score sum, and focuses purely on the profile shape, on the ratio between attributes. Now notice how S3 jumped from third to second place. Its profile ratio was very similar to the target, even if the raw numbers were different. See, raw numbers were different, raw numbers were high. You can see how it got from the third place, second place to third place, and third place to second place. Now the new rank S1, S1 is the greatest, S3 is the second, then S4, then S2, and the least is S5. How did we get that? Normalized each student's vector to unit length, recompute Euclidean. Normalize both, and student vector and query vector to unit length and computed Euclidean distance between the normalized vector. This is the standard way to compare directions, only directions, right? This is the standard way to compare directions only. Now, ranking most similar to least similar, similarly that we have done in the second last slide, right? S1, S3, S2, S1, S3, S4, S2, and S5. Normalization emphasize vector direction, obviously, relative balance between attributes rather than absolute magnitude. S1, S3 remains the closest to query in direction. Now, in the table, it is written normalized vector rounded, so you can see S1 is to all the vectors, normalized vectors, and Euclidean distance to normalized x, and you can understand how did we get the ranking most similar to least similar. And this was my time. Thank you. My name is Jalaj Mehta. My roll number is IC2K2344, MCA 5th SEM, Section A, and I am from DAVV IIPS. And the images that we have used are from these websites, right? And thank you for your time.